Hi, in this video, I coded it so that I solved the halting problem. Just kidding, that's actually not possible, and we'll be going through a very loose proof of why. Before we can get into the actual proofy parts of it, let's go through what the actual halting problem is. In our world, everything runs on code. Our planes are piloted with coded software, our stock market runs on code, there's even code keeping nuclear reactors in check. All of this code is essential to running basically everything in our lives. What this means is that if it failed, if there was a bug, then the world would actually be doomed, especially in the nuclear reactor case. So, wouldn't it be really helpful if we could somehow check to make sure that all the code we write actually works? And by actually works, I mean in every possible case, especially edge cases. Basically, we want to see if our functions, our code, will return the correct result every single time. This is a pretty complicated question that incorporates a lot of CS principles, but we can simplify it by just asking, will our function return a result, or will it run forever? Restated, we get, given a program P and an input W, does P of W halt, aka return, or hang, aka run forever? Okay, so now that we've kind of understood the basics of what the problem is and why it's important, let's get into the proof. Let's pretend that we have some halting function already written. Let's call it halts. Halts takes in two parameters, a function P and an input W. This function returns true if the program inputted will halt at that input, and false if it runs forever on that input. Now, we're not actually writing this function because, spoiler alert, it doesn't actually exist. It's been proven, and we will be proving, that this is not actually a possible function. But let's just assume, for the sake of contradiction, that we somehow magically have written this function. Now, let's create another function called k, which takes in a program as a parameter. This function is basically going to invert the halts function, which we wrote above. It's created with a simple if-else statement. If halts is true at k, comma k, then we want to hang, which we'll do using a while true pass loop, which is basically an infinite loop. Otherwise, in the else case, we want it to return. So the else case will only happen if halts is false. So as you can see, this is basically just inverting the halts function. Okay, so now what happens when we call k on itself, so k of k? Well, we're not actually sure if it halts or not, so let's make cases to case on it. Our first case is, if we assume that halt is true, then following our k function, we can come to the conclusion that it hangs. But that's a contradiction because we assumed that it actually worked, that it actually halted. Sounds weird, right? Okay, let's try the other case. So here, we assumed that halts of k comma k is false, which means that we're saying it should hang. But if you look at our k function, when you call it on itself, it actually ends up halting. So this is also a contradiction. Thus, since we've tried both cases and come up with contradictions both times, we can conclude that the halt function cannot exist. So what does this conclusion actually mean? Well, it basically means that we have no idea if our functions and programs actually work for every possible situation. And this is a really, really dark, grim conclusion. We could all be at risk of a nuclear winter right now. But don't worry, it's not actually all that bad. We can tell if some types of functions are correct or not, and this is a really, really big area of research in computer science. In fact, you can even get a Turing Award, which is like the Nobel Prize of computer science, for finding certain halting functions and expanding the number of programs that we can correctly test for halting. And another bonus is that even though we can't be 100% sure about our programs, we can have lots of test cases to make sure that they mostly work, which is usually good enough. And finally, we have humans. I'll tell you a brief story of Soviet Colonel Stanislav Petrov. Back in 1983, the US and Russia were in the middle of the Cold War, and both countries had massive stores of missiles waiting to be used. If either side attacked, the resulting battle would have destroyed the world. That's how much firepower they had. One day, the Soviet missile detection system noticed a missile coming towards Russia. Protocol was that they retaliate back immediately. But Petrov ignored this because he thought it was a false alarm. And luckily, it was. Turns out the software had a bug that somehow thought the moon was a missile or something. Thankfully, because there are humans in charge, the world was not doomed that day. And so, even though the halting problem has a pretty dark answer, it's not all doom and gloom.